this video, I want to show you how to create your own private network over the internet, VPN-like in a mesh that you can control using the Nebula open source global overlay network from Slack. Slack comes with a great concept, creating this mesh network over the internet, almost like mesh VPN, almost like a MPLS, like if you want to think about it, it's magic. It's scalable, it's secure. You set up your concept, and the way it works is basically you set up a lighthouse. The lighthouse is basically a server connected to the internet with a public static IP address. And what it does is actually lets you connect internally for many servers, many hosts, no matter where they are, even if they're behind a firewall, as long as they have opened the port allowed on the lighthouse, which typically runs on 4242. What it does is actually let the user open the connection and register. They have a PKI keys that you can control, you can set up, you can have whitelisting to set up only the IP address you want. So multiple folks that actually connect, they register to this lighthouse with the public keys. Once they register, the beauty about that is like this manage some kind of routing table from the IP source and destination, and ultimately ends and make it an Ethernet bridge between all the servers connected, regardless of whatever are behind the firewall. So this is super cool, scary stuff, because actually it can bring a lot of insecurities. The good thing about it though is like you don't have a shared pool of lighthouses with everybody or something that you don't know. You control your own IPs, you control your own ports, even if it's a different port. Slack did a great job creating this for their solution under Slack. And I'm gonna follow this link. I wanna put in the show notes that define the working and some of the things how they went there and put in some of this for the scope of this video. I wanna use the distribution that I built, the DenOS, my DenOS minimal Debian distribution, about 300 meg. It's a live CD version of Debian, which I wanna virtualize 3 virtual machines in my laptop. And we also want to follow the code, the source code installed from Nebula. It's on GitHub. And the particular release we're going to be using is going to be the 1.4. With all that said, without any other further ado, let's go ahead and dive into the environment. Oracle VirtualBox. It has, the mean is going to be the server, 2 is going to be the laptop, and 3 is going to be your lighthouse. Basically, if you can see here, the only thing this has is a live 300 meg, 357 meg, my Debian DenOS live the Linux, and this is breached. It's going to be one of the lighthouses. This is going to be the laptop connected, which is same thing, and it's breached. And potentially, just to demonstrate the concept of the tunnel, we want to go ahead and take a look to this one, which the network is NATed. So there's no connectivity between the NAT and the bridge at this point, not at least directly from one way to another one, but we want to demonstrate how that works conceptually in VirtualBox. So let's go ahead and set up the lighthouse. I want to start the DenOS, the Debian Linux here, the Debian Linux, the live CD, the DenOS. And it's going to be really quick. This is the live distribution I added with a live user. So eventually we should be able to just go ahead and get started right away. It will take a second. So once it's there, it's very fast. We should be able to log in as live user. And then I should be able to escalate as root. And I did. Maybe type the right or the wrong password. And then root. So change host name to lighthouse 1. Lighthouse 1. That's going to be the lighthouse for this video. Let's see, host Nebula. In case you have many lighthouses, this could be the lighthouse can be just a simple $5 a month hosting. It doesn't take any resources. You see this lighthouse right now. Live. I can check my IP, which is 192.168.1.7. So with that said, I should be able to SSH remotely with an SSH client to that IP. 1.7. That's going to be the port 22. I should be able to use the live user. And there I am. Good. I should be able to copy and paste some commands and go from here. So good deal. We have started our first lighthouse. It's just a regular regular Debian, which is actually almost no resources, 350 megs. The Debian Live DenOS. Anyway, let's go ahead and the first thing I want to user Nebula. I'm going to put a password, Nebula password. I want to create a user local bean. So let's go ahead and do that. User Nebula password for Nebula. All this is a live CD, so it's going to go away when I reboot the machine. So no worries. I also want to create the user local bean Nebula. Go ahead and paste this one. So we have a placeholder to install. Let's go ahead and do, we will need apt-get, wget for this exercise. So let me go ahead and do the package manager, apt-get to install wget. Yes, I want to do it, install it, connect it to the internet, get your package, get it done. And let's go ahead and swing back to, let's become the user Nebula, and we should be able to get the Nebula from the GitHub repository. So let's use Nebula. And then I should be able to go ahead and paste the wget command. This is right here. I should be able to uncompress it. Nebula for the AMD 64-bit architecture. TART ZXBF. I can see it uncompressed Nebula and Nebula cert. There were two files. I can go ahead and exit from the Nebula user. I can copy move those files from the Nebula to the user local bean Nebula, and I'm on user local Nebula, and I have exactly that, the Nebula and the Nebula. So the two binaries that I copy and downloaded, they're located now on user local bean Nebula, which is good for the exercise. So what we're trying to do is great. Now let's go ahead and start getting something. Let's create our own certificate. I want to use the Nebula cert to create a certificate called DenOS. It doesn't really matter, whatever it fits your needs. Your name of the company, you create a certificate, and then actually let's go ahead with what this command did. That's going to be an interesting way to see it. Basically, what this command is create a CRT and a key, the private key. You never share the private key. I put a command here right now to do a cat on the CRT, which is the other one's going to be similar. But again, this is a live CD. That's a live environment. All this goes away when I shoot on the virtual machines. But just to give you an idea, it signs the certificate of authority with a certificate and a private key that you're not going to share with anybody. I just showing right now the certificate and show you how I actually create the hashes that is going to be driving everything. Once we have that, let's go ahead and sign. Let's go ahead and sign what we have now as the lighthouse, which is going to be our lighthouse here, the IP address. Let's sign the laptop. Let's sign the server one in case you have more. You can name it whatever you want, but basically what this does, if I happen to execute this command in this, now this doesn't have to be done in the lighthouse. I'm just doing it for simplicity, but you're actually doing another box dedicated for your own it's private keys or store it somewhere else secure. When I did the lighthouse command, it created a lighthouse one cert and lighthouse one key. Likewise, if I do the same thing for every device that actually going to be signing, it's going to start doing exactly that. It's going to create, and in this case, we are the groups. So we have now the groups: the laptop one CRT, laptop one key. And actually, you start expanding and building on that. I also want to have a server. In this case, I want to have a server, so I'll call it server1. It doesn't really matter the name, but as you can see, I'm assigning certain IPs, 105, 109, and you can assign whatever you want. The IP is going to be taken from the certificate. So once you have all that, actually you can create a directory or folder, etc Nebula, and change it to that. Let's go ahead and start in some of the configuration changes. Let's go ahead and do, let's get from the internet curl config YAML. which is actually one of the sample files. They're listed. They're right there as the curl. I want to copy that one to Lighthouse 1 and also basically instead of YAML, YML, it's going to be YAML. So it's going to be just copying the files, uh, the the one we just downloaded to the config Lighthouse 1 YAML and the config ultimately the config YAML, which is going to be driving the service. But let's go ahead and get going. Keep going here. One of the things is we need to edit the file. So one of the things we want to be looking for the Lighthouse. Yes, we want it to be Lighthouse. We need to check the static host map. What is the static IP, the real IP of this device, which is going to be mapped to the port 4242. We're going to add SSH between hosts as part of the firewall rules. And we need to change the PKI's search to actually run what we are configuring at this time. So, with all that said, let's go ahead and do Lighthouse. It's actually config Lighthouse. Okay, Lighthouse. So let's go ahead and do this. The first thing, let's go to the Lighthouse true. It's right here. Shell if so 192.168.1.7. 192.168.1.7. Now, for the scope of this is where it's going to be your external IP from your hosting company, and you can see it's going to be using 100.1 as the internal IP within the Nebula network on that. So it's going to say yes, it's going to be a Lighthouse. Yes, this is going to be the IP, which could be it's going to be the external routable, accessible for everybody who wants to be part of this network on port 4242. You can change the port as well. And internally, it's going to be once it's mapped internally, it's going to be 192.168, 100.1. Feel free to change the subnets and masks as you need to. It's not actually something written in stone. Let's go ahead and add SSH to host. Some things on the firewall. If we scroll down all the way to the bottom of the configuration file, you can see that actually we have some flexibility here. Let's allow ICMP to copy 4 lines here. I'm going to say allow SSH. The protocol is TCP. And the port is going to be. So I'm allowing SSH between hosts. And the last change I want to do here is actually tell them on the search on the PKI key that is Lighthouse 1 and Lighthouse 1 key. So let me go ahead and go back here. It's not really the host here, so I'll call it Lighthouse 1. Lighthouse 1 key. That's about all she wrote. That's about all we need to set up our certificate for the Lighthouse. Now let's go ahead and copy some commands. I'm going to copy the Nebula Lighthouse to the etc. Make it the Lighthouse 1 as the config YAML file. Let's copy the certificate from the user local bin as the etc Nebula so it can be a certificate be ready. And also let's copy the Lighthouse 1 to etc Nebula so it's going to be accessible. Some little helpers once we're in etc Nebula. We can see that we have about 4 files. We have the config, a YAML. Really, we don't need the YML, but we can just clear them out the house over here. Really, we don't need that one. That was just the one we downloaded as a sample. You can remove that one. So in the EC Nebula, we only have the certificate, the certificate authority. We have the config Lighthouse YAML, the config YAML, and the Lighthouse, which is this box, CRT and the key, the private key, all owned by root. Check out the permissions, all on the readable by root as well. So it's very important to actually keep security in mind, right? Also, we're gonna copy. We can execute this one, and we can start it as far as the config. Let me see the config. One more time. Just want to make sure it's the Lighthouse. Typically, we should be able to just go ahead and start it with the command user local v nebula pointed to the configuration file. So if I do that, actually it's Nebula. There's a little typo here because Nebula is called, yeah, Nebula is the. Okay. With all that said, actually that started lighthouses in config. It seems to be up and running and working. So that's about all the work we have to do to actually get the lighthouse up and working. So let's go ahead and work in the client files. There's some things that actually we may need to do a configuration. I want to stop it for a second here. And what I want to do is I want to open a screen to go ahead and prepare the client files. I want to create a folder, home Nebula client. This is change the permissions on Nebula. This is actually just a local recipe, just to keep everything on the client so we can propagate. So in case you want to do some automation, you focus only on those files. You want to copy the etc Nebula. I want to copy the etc Nebula CRT. We want to copy the laptop one CRT from user local and the laptop one key. We want to set up first the laptop. So we're going to execute those 4 commands into the etc Nebula client. Now check this out. We need to really change the permissions to this to 004. Why? Because if I do ls-l home Nebula client, you can see the permissions is not going to be readable. We're not going to be able to actually copy it over the internet to get there. So I want to add the permissions to read, just to read on the Nebula users. This is an etc Nebula. So the only thing we're doing here, I can go back then and perhaps open another screen here and start again. Nebula. Good deal. So with Nebula running, let me go ahead and let's set up the laptop one. So we need to go ahead and go to the laptop or the server setup, whichever be the case. So in this case, let's go back and I'll open the second box, which is going to be the laptop. The laptop is breached. It's going to have, yes, I know it's going to have connectivity for this exercise, but if it would not be in the same subnet, it will be some different subnet, it will be the registration. My point is, within VirtualBox, I was not able to just create that separation, but it's breached, but eventually it's going to be connected to the private address, not the public address. And you see the interface is being created. So just sure. So I want to create this one. I want to change host to laptop one. Host. One. It. Of course, it's going to be the wrong one. That was, okay. Laptop one. 1.8. Okay, so I should be able to open an SSH tunnel, likewise, like we did in the other one. This is for the 1.8. Some bridge mode in VirtualBox 68.8, and I should be able to log in as the live user. And there I am, laptop one. Good deal. So with all that said, let's see, I can just go ahead and move it here. Let's go ahead and do the similar things we did here. Let's go ahead and add a user, just for simplicity, consistency. Grab, not necessary. I just prefer to keep things open. So password, and then I can create a user local v Nebula to keep my binaries. And I will need to do install wget. Okay. Then we're going to become user Nebula. Install. And then let's go ahead and get us the binary, which is that version. Let's uncompress it, tar, and then can actually exit from here, go back to the root environment, and move it to user local bin. And there they are, the binaries for Nebula, same versions. Let's go ahead and create an etc Nebula and change to that folder as well. And now, because we copied the previous files on the Nebula client on the laptop, I can execute the command from the 1.7 from Home Nebula, everything here on etc Nebula, and I can use the password on Nebula little one. I ended with 4 files: the certificate of authority CRT, the config YAML file, which is the same file from the Lighthouse, and in this case, I'm copying the laptop and the CRT key. So what I'm going to do is actually change the permissions back to what it was supposed to be on the server. Very important. We care about permissions. We don't want somebody hacking the system. You see, right now we remove the read-only, so eventually this is owned by root, as will be managed by root, and only handled by root. With all that said, let's go ahead and take a look to the configuration file, the YAML file. And this is not going to be a Lighthouse. This is actually the laptop, so we're going to change it true to false. And then the static map internal, we are connecting to a Lighthouse, which is 101, 1.7, and 442.42. If you happen to connect to different port, that's where you have to set it up, just like that. This is not going to be the PKIs, are not going to be for the Lighthouse. It's supposed to be the PKIs for the laptop one. That's how we sign it. And that's the one that's going to have the configuration for IP addressing. Laptop 1 key, and that's about it. We already have the TCP connectivity. So typically, called Nebula. We should be able to start Nebula right now on the laptop. So if I do this, voila, it connects. You can see actually, let me go back and open the other screen for the Lighthouse. And you can see the handshake was received and sent from both ends. So actually we have a handshake on the left, on the Lighthouse, on right here. If I go back here, I can do if. You can see it created a Nebula, a tap interface, 105. If I go do a ping, 192, 168, and 101, I can see the Lighthouse. But not much fun right now because these both are knotted, you would say, and they were in the same subnet. So let's go ahead and carry on with this video, and let's go ahead and boot up the one is knotted. That would demonstrate a concept that things behind a firewall can actually be creating the UDP hole punching and eventually do the connectivity among all those things. It's becoming very popular and the guys playing video games. It's becoming really popular connecting. Scary for the security guys because some other alternatives, they're not really checking for things in terms of security. You have to really check in endpoint clients on the firewall. It's not really as trivial. So let's go ahead and do start live, come through. This is going to be server 1, so I'm going to post name server 1, PC host. I'm going to call it server 1, for VI, exit, this lecture here on the live, out, okay, live server 1, config, yeah, I don't like it, the path, 10.02, as you can see, it's not it, 10.02.15. So I created previously some kind of a translation on VirtualBox, and I should be able to go ahead and do the translation locally to localhost at least 2022. Let's see. Yep, server one. Okay, we got it. So right now we have the server one. Server one, want to repeat exactly the things that we did from laptop one. So let me go ahead and bring it back, our little cheat sheet here, which eventually could be a nice way to customize some Ansible or something, right? I want to see the laptop one. Let's go ahead and add a user. Let me go ahead and add it to root. User add. This should work for any distribution. This doesn't have to be this particular distribution. Any Linux distribution should work with this. Is it correct? Yeah. Okay. Sure. Okay. So, yep. Give me wget. I want to become Nebula, and I want to get the Nebula package. It'd be nice to have these packages already packaged on the Debian repositories. You can add some of those things. I'm sure they want to continue developing on that. I like to see the status of the connections as well. I like to see some kind of added, even some folks on Ubuntu world, they added to the system controller services, which would be kind of nice to see and control and eventually see what the status on the rules are. I think eventually it's going to evolve. This is a super cool project. I'm really excited about this. I think it's just going to get better, and more services going to start adding lighthouses all over the place, and maybe, who knows, client-less functions on AWS or something that eventually can perform those functions, give those little IPs and port tables. But anyway, I create let's follow the recipe. We have the 4 files. Oh, something here. We don't want the laptop certificate. We need the server. So let's go back to the lighthouse. That's something that we see. Got excited here on this part. So really, let's see, you go in Nebula. This is where I have the certificates for server one. So what I need to do is Own Nebula client. Really need to remove the home Nebula client, the laptop key, copy server home Nebula client. Yeah, I had to change the permissions as well. It was something that I did when I copied earlier in the preparation. I changed the permission so it's going to be readable by Nebula and report it back. All right, I give it the permission, now it's server. Good deal. I can copy the files now. Let me go back to the server. So realistically, I can remove everything here, repeat the last command. Now I got the right file because it has server one. Beautiful. And now, once I copy everything back, I should be able to shemot, and now the permissions are correct, the ownerships are correct. Let's go ahead and BI on the YAML or the config YAML file. This is not a lighthouse, this is actually the server, which is going to be default. This is actually another PKI search for the lighthouse. Going to be for server 1. Everything else stays the same. What all she wrote right here. Let's see. So Nebula, two binary files. So I have the binaries, I have the configuration files, I have the certificates, I have everything in place. I should be able to do fire in the hole. Before I hit enter, I want to put in the background the lighthouse so you can see what exactly happened here on the handshaking. Go to server, I'm gonna hit enter. See how fast it was. Handshake send and actually found it. I was able to find it from one to another one. So now I should be able to ping the one. I can see the lighthouse. Let's see the laptop. I can see the laptop. That's pretty awesome. And the traffic, if we put a traffic on like T-Shark, we could demonstrate that the traffic never goes to the lighthouse. Everything just among the hosts, when actually that's intent. Just to finalize this exercise, let me go to laptop 1 on Nebula. I'm gonna do echo. Text file called, let's say, Nebula Rocks, and just from the inside network on the NAT connecting to something that is breached, I can Nebula now. Nebula on the 5 on reverse degree. How about that? I got it. Connectivity done. Pretty sweet. Now, again, from this end, folks behind a firewall opens UDP port, goes outside. How you going to stop? The firewall is not going to stop that. Everything happens right there. The good thing about this, you control your PKI keys. The translation table is right here, the TCP and the ports. So everything goes back. And ultimately, when the UDP hole punching happens, everything's internal right here. You have full control of everything. Do not trust something that actually gives you a man-in-the-middle attack. Some other solutions out there in here, they're very easy, very simple, but it's a recipe for disaster. Do not let anybody control your lighthouse. Do your own lighthouse. Do your own things. Do the things safely and secure. Do not take security lightly. There's a bunch of guys out there that actually are trying just to get to your data. This is becoming very, very impressive. How to actually they can embed a little piece of code and eventually breach your network completely. As you can see, all the things are the same. There's perfect use cases to actually do this, but potentially it could be a problem. Um, anyway, really cool. Gamers will take a lot of advantage of this. They will really like it. They're using it. If you want to do it, definitely it opens a whole world of possibilities. What happened if instead of just a Debian box in this one, we enable IP routing? What happened? We start putting a routing protocol. You potentially can create your own MPLS network end to end, and you could put BGP, you can put Lisp, you can put anything else. You can connect and wire everything. The world of networking and connectivity is becoming incredibly amazing. But like Spider-Man in the movie 2, Uncle Ben said to Peter Parker, with great power comes great responsibility. Again, do not take security lightly. Take it really, really seriously. Hopefully you guys enjoyed this video. It took a lot longer than I wanted, but I think it turned out really good. Play with Lighthouse, give it a shot. This video is going to be listed for reference, but kudos for Nebula and the Slack project. Hopefully everybody stay safe, stay well, and see you guys in the next video. Thank you for watching.